Example 5. What we're getting to tomorrow, or actually on Thursday, is going to be word problems with differentials. And this is kind of a primer to a word problem. This is kind of the stuff you need to know out of a word problem to be able to do a differential, or to use differentials to do anything for you. If it says find the differential of that and evaluate dy for that. Alright, so it goes back to the part of the example 3 that we did today, where it said to compare delta y and dy, and where we found dy. We had a function, we had x, we had delta x, right? So that's what we have here. We have a function, y equals cosine of x. We know what x equals, and we know what delta x equals, so we're going to approximate that as dx. Alright? So whatever delta x is, and when we get to word problems, delta x is going to be called the error. Okay, what's going to happen is they're going to be measuring things. The beam was measured to be 15 feet long with an error of at most 0.05 feet. Because when people read a tape measure, they aren't perfectly accurate, right? Maybe it slips a little bit, maybe they didn't read the line properly. So there's always that possibility of error when you're measuring things. That's what the delta x is going to be when we're doing word problems, the error in measurement, where x is going to be the actual measurement. Alright, so they're going to be giving you that kind of stuff. Alright, find the differential of that, evaluate dy. So basically, if I go to y equals cosine of x here, and I do the derivative of y, which is 1, then I put a dy on it. The derivative of cosine of x is negative sine of x, and I put a dx on that. Alright, there's my dy, and they want me to evaluate that. They've given me what x and dx equal, officially, because we're going to call dx the same as delta x. If delta x is some large number, you're not allowed to do that, but the fact that it's tiny, that allows us to make that assumption those approximately are the same. So, dy is going to equal negative the sine of pi over 6 times dx, which is 0.05. But you know what the sine of pi over 6 is? If I'm here at 0 and I go up one step, which is where pi over 6 is, and sine is the y value, what's sine of pi over 6? 1/2. Very good. It's one step above 0. 0, 1/2, square root of 2 over 2, square root of 3 over 2, 1. Remember that? Our little unit circle deal? Alright. So, sine of pi over 6 is 1/2. That's negative 0.5 times 0.05. That comes out to negative 0.025. So dy is equal to negative 0.025. So if they ask you to evaluate a differential, that's all they're asking you to do. Find the differential, substitute x and dx in, and get the answer, circle it, and you're done. Alright? And that's what your homework's going to consist of tonight. Problems that we saw today, problems of that variety. Find the differential. That's every differentiation rule you've ever learned. They're fair game, but then put dx, du, and d whatever letter next to each thing. Evaluating differential is going to be pretty much like this. They'll tell you what x and dx are. You do dy and then substitute the numbers into working out.